When writing Python scripts for security automation, you will inevitably encounter situations where your code tries to do something that fails at runtime, opening a file that does not exist, connecting to a server that is offline, reading malformed data, dividing by zero, or trying to access a dictionary key that is not there. These situations are called exceptions. If you do not handle them, your script will crash abruptly, which is unacceptable in a professional security context where scripts must run reliably, sometimes unattended, against dozens or hundreds of targets. This chapter teaches you how to anticipate, catch, and react to errors in a controlled and explicit way using the try/except mechanism in Python. What is an exception? An exception is an error that occurs during the execution of a program. Unlike syntax errors, which are detected before the program runs, exceptions happen while the code is running. When Python encounters an exceptional situation it cannot handle on its own, it raises an exception object. If nothing in your code catches that exception, Python stops the script and prints a traceback message showing where the error occurred. For example, if you try to open a file that does not exist, f equals open targets.txt, r. Python raises a file not found error. If you try to convert a non-numeric string to an integer, port equals int abc, Python raises a value error. If you try to access a list index that is out of range, my_list equals 1, 2, 3 print my_list 10. Python raises an index error. Each type of error has its own exception class name, and understanding these names helps you write precise and targeted error handling. The basic structure: try/except. The fundamental syntax for handling exceptions in Python is the try/except block. Here is the structure. Try. Hash code that might raise an exception. Except exception type. Hash code to execute if that exception occurs. The try block contains the code you want to execute. If an exception is raised inside the try block, Python immediately stops executing that block and jumps to the except block. If no exception occurs, the except block is skipped entirely. A concrete example in a security automation context. Try. F equals open host.txt, r. Content equals f.read, f.close, except file not found error. Print error, the file host.txt was not found. In this example, if host.txt does not exist, Python raises a file not found error. The except block catches it and prints a meaningful message instead of crashing the script. Catching multiple exception types. You can handle different types of exceptions separately by chaining multiple except blocks after a single try block. This lets you give specific responses depending on what went wrong. Try. Port equals int input enter a port number, comma result equals 100, port except value error, print error. Please enter a valid integer, except zero division error, print error, port number cannot be 0. Here, if the user types something that is not a number, a value error is caught. If the user types 0, a zero division error is caught. Each case is handled independently and explicitly. You can also catch multiple exception types in a single except line by grouping them in a tuple. Except, value error, type error, print error, invalid input type or value. The except without a specific type, a bad practice to know and avoid. Python allows you to write a bare except block that catches every possible exception. Try. Risky operation. Except. Print something went wrong. This is generally considered a bad practice because it silently catches all errors, including unexpected ones that you did not anticipate, such as keyboard interrupts or memory errors. It makes debugging much harder. In a security automation context, hiding errors can be dangerous. Your script might silently skip a target or fail to log a critical finding. Always prefer catching specific exception types. Using except exception as e to get details. When you catch an exception, you can bind the exception object to a variable using the as keyword. This gives you access to the error message and lets you log it or display it for debugging. Try. F equals open report.txt, r except file not found error as e. Print file error, e. The variable e contains the exception object. When converted to a string, it gives a human-readable description of what went wrong. This is extremely useful in scripts that run automatically, where you want to log errors to a file or display them with context. You can also use the generic exception class to catch most standard exceptions while still being able to read the error message. Try. Risky operation. Except exception as e. Print unexpected error, e. This is acceptable when you genuinely do not know what exceptions might occur, but you should use it carefully and log the error properly. The else clause. The try/except block can optionally include an else clause. The else block runs only if no exception was raised in the try block. It is a clean way to separate the code that should run only on success from the exception handling code. Try f equals open host.txt, r except file not found error. Print file not found. Else. Content equals f.read. Print file read successfully. Len content, characters, f.close. Using else makes the intent of your code clearer. The try block contains only the risky operation, and the else block contains what to do when that operation succeeds. The finally clause. The finally clause is another optional addition to try/except. The finally block always runs, whether an exception occurred or not. It is used to clean up resources, such as closing files, closing network connections, or releasing locks. Try f equals open targets.txt, r. Content equals f.read, except file not found error. Print file not found. Finally. Print cleanup done. Script continues. Even if an exception is raised and caught, or if no exception occurs, the finally block executes. This guarantees that cleanup code always runs, which is critical in automation scripts that open connections or files. A more complete example combining all four clauses. Try f equals open log.txt, r except file not found error as e. Print fairer. E. Lines equals f.read lines. Print f len lines, lines read, f.close. Finally. Print operation attempted. Raising exceptions manually with raise. Sometimes you want your own code to raise an exception intentionally. This is useful when you are writing functions that validate input and want to signal to the caller that something is wrong. Def validate _ port. If port less than 1 or port greater than 65,535. Raise value error f invalid port number, port return port. Try validate _ port 99,999, except value error as e. Print validation error, e. Here, the function validate _ port raises a value error if the port number is out of the valid range. The calling code catches it and handles it appropriately. This pattern is very common in security scripts that validate IP addresses, port ranges, file paths, or other user-supplied inputs. Common exception types you will encounter in security scripts. Here is a reference list of the most common exceptions you will encounter when writing security automation scripts. File not found error, raised when trying to open a file that does not exist. Permission error, raised when trying to access a file or resource without the required permissions. Value error, raised when a function receives an argument of the right type but an inappropriate value, such as converting ABC to an integer. Type error, raised when an operation is applied to an object of the wrong type. Index error, raised when trying to access a list element at an index that does not exist. Key error, raised when trying to access a dictionary key that does not exist. Zero division error, raised when dividing a number by 0. Connection refused error, raised when a network connection is refused by the remote host. Timeout error, raised when a network operation times out. OS error, a broad exception that covers operating system-related errors, including file and network issues. Attribute error, raised when you try to access an attribute or method that an object does not have. Import error, raised when a module cannot be imported. Understanding these names allows you to write targeted except blocks that respond specifically to each failure mode. Applying exception handling in a security automation script. Consider a script that reads a list of IP addresses from a file, tries to connect to port 80 on each one, and logs the result. Without exception handling, a single unreachable host would crash the entire script. With exception handling. Import socket. Try f equals open targets.txt, r except file not found error. Print target file not found. Exiting. For line in f. IP equals line.strip. Try sock equals socket.create _ connection IP. 80, timeout equals 2. Print FIP, 80 is open, sock.close, except connection refused error. Print FIP, 80 connection refused, except timeout error. Print FIP, 80 timed out, except exception as E. Print FIP, unexpected error, E, f.close. This script handles the file not found case at the top level, then handles connection errors individually for each host. The script never crashes midway through the target list. This is exactly the level of robustness expected in a professional security tool. Key principles to remember. Always anticipate failure in automation scripts. Files may not exist, networks may be unreachable, and user input may be invalid. Always catch specific exception types rather than using a bare except clause. Use the as keyword to capture the exception object and log meaningful error messages. Use else to separate success path code from error handling code. Use finally to ensure cleanup always happens, regardless of success or failure. Use raise to signal errors intentionally from within your own functions. Exception handling is not just about preventing crashes. In security automation, it is also about ensuring that failures are visible, logged, and handled in a predictable way, so that your results are reliable and auditable.